I know you're not in this mode. I know. But go ahead and number 1 through 4 on your warm-up sheet. 1 through 4. And the last thing that we learned was rotations. Turn your volume. We learned rotations was the last thing we learned. And let's see. Shelby's not here. Torrin's not here. Matt, how many degrees do we rotate at a time? Yeah, you know it. 90 degrees at a time. Okay, so we learned last week, we learned the rules for rotating 90 degrees, for rotating 180 degrees, and for rotating 270 degrees. And those are in your notes. Do you have to memorize those?
No.
No, because we're going to give them to you on your test. And they're actually right there on the whiteboard. See right there? So I need you to determine what has happened to that point. How many degrees that point was rotated. You have 2 minutes. Oh, let's do number 1 together.
90 degrees.
Okay. So on number 1, what happened from here to here? Let's see. XY became, what's this one? That's negative X or negative Y?
Y.
This is the Y value. 3 was the Y value. So that's negative Y, comma. Oh, we didn't do anything to X. That's just plain old X. So which rule is that on the board? You see negative Y, comma X? That's the 90 degrees. So the answer to number 1 is 90 degrees. Do number 2, 3, and 4, please.
What? You want my help? Okay.
No, you don't even need help. You just look at the board and you look and see what happened to the numbers.
Oh no.
1, 2, 3, 4, 5, 6, 7, 8, 9. There's a lot of people here. That's a lot of people. More than half the class is here, so we're going to proceed. Ashley, what'd you get for number 2? Ashley, what'd you get for number 2?
1.
Okay, I just like the way you said that. Okay, so what is this one? What happened from here to here? Negative. Okay, so that's negative X. What happened from here to here?
Negative Y.
Negative X, comma, negative Y. So then you look at the board, the rule, 180 degrees. Not here. Catherine, number 3. What is that first one? What is 9? Is that X or Y? From here. That's Y. And is it Y or is it negative Y? Well, it's positive, but what could you do to that number to make it that number? Hey, girls.
Sorry, it's been a while.
So is this
Negative
plain old
Y.
Y or is it negative Y?
Negative.
It's the only 2 choices.
Y.
It's negative Y, because when you make a negative, it becomes positive. Okay, and then what about 4? Is it, I'm not asking you, Kendall, I'm asking Catherine. Is it X or is it negative X? Did we do anything to X? Yeah, we didn't do anything to it. Okay, so which rule is that, Catherine? 90. Okay, so number 3 was 90. And not here, and Kendall, number 4.
90 degrees.
You're wrong.
You are wrong. Let's document what it is. Okay, what's this one? That's Y. What's this one? Negative X. Which rule is that? 270. You had to know we were going to use all of them. I mean, we hadn't used 270 yet. You had to know that one was coming. Come on. All right, I'll come get your warm-ups. If you can find, that was the answers to the worksheet, but okay, we'll come back to that. Okay. If you can find your notes, that'd be awesome. If you couldn't find them, then you'll just get to watch. So, a dilation. What does it mean to dilate something?
Make it smaller.
Smaller or larger. Grow or shrink. Okay? So, what we're going to do is, if you want, find someone near you. Okay, so you have, and you two. Huh? y'all can do it, and y'all can do it. Okay, so you're going to make eye contact while I count to 5, and you're going to look at their pupils. And then I'm going to turn the lights out, and then I'm going to turn the lights back on, and you stare at their eyes, and you see what happens to their pupil, and it should dilate. Okay, so
I did this in elementary.
I know it's awkward, but do it. Stare at their eyes.
Elementary school.
Stare at their eyes. Ready?
Stare into his eyes.
You're not going to see a difference unless you look at it.
Wait,
Okay.
you're doing Kendall.
This is as dark as I can get it. Okay. 1, 2, 3, 4, 5.
I wasn't even looking.
Did you look at-
What are we doing?
Oh, you stare at their eyes, at their pupil, and I'm going to turn the lights out. When I turn the lights back on, you should see the size of their pupil change.
Esma's eyelashes are too long.
Oh no. Okay, ready? Okay, 1, 2, 3, 4, 5. Stare at their eyes. Go.
His eyes are too chinky.
Ugh.
What is that?
Okay. So what's supposed to happen is in dim light, your pupil gets larger. And then in bright light, it should close up. It should get smaller. And your iris is bigger. Okay, anyways, if you're on your notes, we're filling in the blanks. Who has their notes? Come on.
I don't have my
Awesome. So, a transformation that enlarges or reduces. That's where you write down. Enlarges or reduces the size of a figure proportionally. When you dilate something, the figure is similar to the original. It's similar. The symbol for similar is a squiggly. What was the symbol for congruent? What was the symbol? It was an equal sign with a squiggly on top. So that's congruent, that's similar. Congruent, similar, congruent, similar. Hey, you three. Hey, Ashley and Kendall. Maybe Kendall, maybe you need to sit somewhere else. Kendall, I'm talking to you. Maybe you need to sit somewhere else if you can't handle it right there. So, equal sign with a squiggly on top means congruent. Plain old squiggly means similar. Congruent is same size, same shape. Similar is just same shape. The size is going to be different, obviously. We're changing the size. All right, so take a look at my example. What happened?
It got small.
How do you know which one's the original, by the way? How do you know?
Oh yeah, the little prime. The prime.
A, B, C, D, and I don't know where the E went. A, B, C, D, E is the original, and the ones with the primes is definitely the image. This is called the pre-image, this is the image. So was this an enlargement or reduction?
Reduction.
Okay, obviously it got smaller, right guys? Right? And now we need to find we're going to find what's called the scale factor. Like how much smaller did it really get? So,
Seven students, please pardon this interruption. Teachers, if you are testing, if you will accept students until 7:45, once again, the teachers that are testing, if you will accept students to your testing room until 7:45. After that, we'll have a plan for late arrival. Thank you.
okay, so how much smaller did it get?
5.
Is it a fourth of the size? Is it a fifth of the size? Is it half the size? Is it? Yeah, that's really easy. It's half. Now, where does half come from? How do I use these numbers and make the number 1/2? 10 divided by 5, what's 10 divided by 5? Ooh, it's 2. Did it get 2 times bigger? So how can I change that? I don't want it to be 2. I don't want it to be twice as big. So 10 divided by 5 was close, Ashley, but it was incorrect. What should it be? What? No, I got to use this number and this number.
10 over 5. Right.
We already tried 10 over 5. It got us 2. 5 over 10. Very good, Ava. So you always put the second number over the first number. What is 5 over 10? It's 1/2. And that's what we wanted all along. 1/2. So the scale factor is 1/2. How do you get the scale factor? Second over first. If you have notes out somewhere on those notes, you need to write second over first. We're on the side, this is dilation. Second over first, second over first. Just write it somewhere, second over first.
Why'd you extremes?
I feel like I'm missing something. Okay, we'll get there. All right, let's try this one. Nasia, enlargement or reduction?
Reduction.
Definitely a reduction. And I'm telling you the scale factor is 1/4. So Britt, what is the diameter of the second sun? Can you read that? That says diameter is 8. This is 8. We don't know this, but our scale factor is 1/4. All you have to do is multiply. So, by the way, when you're multiplying by a fraction, it's the same as dividing. So when you multiply by 1/4, you're just taking the number and you're dividing by 4. Okay, so it got smaller. How much smaller did it get? It got 4 times smaller. 8 divided by 4 is 2. Kendall, you're a major distraction right now. All right. Lewis, enlargement or reduction? Definitely enlargement. How much larger is it? What's the scale factor? It is 3. Where'd you get it? Did you say it? I just thought about it. But remember, how do you get scale factor? Blank over blank.
Second over first.
Second over first. Look at that. 15 over 5. What is 15 divided by 5?
3.
That's how you get the scale factor every time. Second over first. Okay, now we're back to your notes. We're filling in stuff on your notes. Scale factor describes the size change from the pre-image to the image. If it's greater than 1, it's an enlargement. If it's less than 1, it's a reduction. And if it is 1, it's called a congruence.
What is this?
Enlargement, reduction, congruence. Yes, which part? When a figure is dilated, the image is similar to the pre-image. Similar. We're not congruent, we're similar. Very good. So, greater than 1, enlargement. Less than 1, reduction. Equal to 1, congruence. So it can either be an enlargement, a reduction, or a congruence. Anyone need more time? Enlargement, reduction, congruence. Okay. All right, super easy. To the board. Julius, go do A. Megan, go do B. Yasmin, go do C. Travis is not here. Let's say it's not here. Brett, go do D. And Nasia, go do E. Go. You're writing if it's an enlargement, a reduction, or a congruence transformation. And that is the scale factor listed. I think you were D. Julius, you were A. I don't know what that is. All right. Yeah, you can't rest your hand. You have to get used to it. It's fine. So just because you see a fraction, does that mean it's a reduction? Not necessarily. A lot of people are tempted to think, oh, fraction, reduction. But this fraction is greater than 1, and this fraction is greater than 1. So very good. And the only reduction is B, and the only congruence one is T. If you multiply something by 1, what happens to it?
Stays the same.
It stays the same. Anything times 1 is itself. So that's why a congruence transformation is scale factor of 1, because you don't change it at all. Alrighty. Number 1, in your notes, if you have your notes, we got to find the scale factor. How would we find the scale factor? How would we find, first of all, is it an enlargement or a reduction?
Enlargement.
It's definitely an enlargement because this is the original and this is the second one. So we know it got bigger, we just need to know how much bigger it got. How do we do that?
Second over.
Second over first, but, okay, now what? What do we have to find? Yeah, we have to find